Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will talk about memory management schemes. There are different types of memory management schemes that may be pursued by an operating system based on its requirement. The different types of memory management schemes are broadly classified or categorized into two identifiable categories. The categories are contiguous memory management scheme and non-contiguous memory management scheme. In contiguous memory management scheme, we have single contiguous memory management scheme and we have multi-partitioning continuous memory management scheme. Whereas in case of non-contiguous memory management scheme, we have paging and we have segmentation. Further, in case of multi-partitioning contiguous memory management scheme, we have fixed partitioning and we have a dynamic partitioning. Now, in due course of the class, we will try to understand the characteristics of each of these memory management schemes. Now, before moving on with memory management schemes, let us try and understand a very important concept that is called as fragmentation. The free memory space that is present in the computer system is often broken down into little pieces as processes are loaded and removed from the main memory. So, during the course of the process execution, constant migration of process takes place or a part of process takes place in between the main memory and the secondary memory. This constant migration leads to division of the free memory space into smaller pieces, and at some point in time it may so happen that the pieces of the free memory space may not be capable of hosting any process further. So this situation is referred to as fragmentation. So it may so happen that the memory blocks cannot be allocated to the processes considering their size, leaving memory blocks unused. So this is what fragmentation is all about. So it's about dividing the free memory space in a manner that it cannot be further utilized. Now there are two types of fragmentations that are possible. First one is called as internal fragmentation and the second one is called as the external fragmentation. Now let us try and understand what does internal fragmentation and external fragmentation refers to. Internal fragmentation happens when the memory is partitioned into blocks. The requesting process is allocated with the memory block. In situation when the block of assigned memory is larger than the memory requested, then the difference between the allotted and the requested memory is called as internal fragmentation. So internal fragmentation happens whenever memory is partitioned into blocks, and when a process is allocated with a block, then it may so happen that the requested size may be less than that of the size of the block. So here it is destined to create a fragment. So such kind of fragment is referred to as internal fragmentation. So the requested process is allocated with the memory blocks. So in situation when the block of assigned memory is larger than the memory requested, then the difference between allotted and the requested memory is called as the internal fragment. Now likewise, let us try and understand external fragmentation. So it may so happen that there is sufficient memory to satisfy the memory request of the method, but it cannot be allocated as the memory offered is not contiguous. So it may so happen that the overall size of the free memory may be capable of accommodating a requesting process, but since these free memory cells are non-contiguous in nature, so what we cannot do is we cannot allocate the memory to the requesting process. So this situation is referred to as external fragmentation. Now let us create a distinction between internal and external fragmentation. Now in case of internal fragmentation, memory is divided into fixed size blocks and then they are allocated to the process. It happens when a method or a process is allocated space larger than whatever is required by it. The difference between the memory that is allocated and the required space or memory is called as the internal fragment or It's called as the internal fragmentation. Internal fragmentation occurs when occurs with paging and fixed partitioning. It occurs in worst fit memory allocation method. The solution of internal fragmentation is that we need to have a best fit mechanism put in place for allocating free space to the processors. Now let us discuss external fragmentation. Memory is divided into variable size memory blocks and they are allocated to the processors. It happens when the methods or process is removed. The unused space formed between non-contiguous memory fragments which are too small to serve a new process is called as external fragment. External fragmentation occurs with segmentation and dynamic partitioning. It occurs in case of best fit and first fit memory allocation methods. The solution to external fragmentation is compacting and paging. So these are some of the key distinctions between internal fragmentation and external fragmentation. Now, keeping this in mind, let us move back to the memory management schemes. Now let us talk about contiguous memory management scheme. In case of contiguous memory management scheme, each program occupies a single contiguous or continuous block of storage location. Again, I am repeating it. In case of contiguous memory management scheme, each program occupies a single contiguous block of storage location, that is a set of memory locations with consecutive address values. Now let us try and understand single contiguous memory management scheme. Single contiguous memory management scheme is the simplest memory management scheme where the main memory is divided into two contiguous area or partitioning or partitions. Operating system resides permanently in one partition with the user process in the other partition. So in case of single contiguous memory management scheme, the overall memory, that is the main memory, is divided into two contiguous area or partition, wherein operating system resides permanently in one partition with user initiated process residing in the other partition. Now let us go through some of the advantages and disadvantages of single contiguous memory management scheme. Now let us discuss the advantage. So advantage, it is simple to implement and easy to manage and design. Here a loaded process is assigned full processor's time with no interruption, because there is only one process that is to be executed in the user space. So here a loaded process is assigned with the full processor's time with no interruption. Now disadvantages, it can execute only one program at a time. So this is one of the biggest disadvantages. So it can execute only one program at a time. It can execute the program only if it fits in the main memory space. So this is also one of the requirements. So it can execute the program only if it fits in the main memory space. The CPU stays idle during the loading process. So this is also very true. Whenever the process is being loaded from the main memory, from the secondary memory onto the main memory, then the processor remains idle. So the processor remains idle during the loading process of the program. It makes a non-optimal use of memory. So definitely it makes non-optimal use of memory because there is only one process residing in the free space, whereas it could have been used for hosting many processes. It makes non-optimal usage of processing capabilities. So since only one process is executing, so definitely it makes non-optimal use of the processing capabilities. It does not support multi-programming. So it is understood. So since there is only one user initiated process that can be executed, so it does not support multi-programming. That is, simultaneous execution of multiple processes are not possible. So these are some of the notable advantages and disadvantages of single contiguous memory management scheme. Now let us talk about multi-partitioning memory management scheme. Here, the operating system divides the main memory, the available main memory, into multiple parts to load multiple processes into the main memory. So here the operating system divides the free memory into multiple parts or multiple partitions to load multiple processes into the main memory. Thus, multi-processes can reside in the main memory simultaneously, facilitating multi-programming. Thus, the degree of multi-programming is also obtained as there are more number of partitions that can host more number of programs. When the process terminates, the partition becomes available for other processes. So this is very true. So whenever a process terminates, then the partition becomes available for other processes. Now, there are two types of multi-partitioning memory management scheme. One is called as fixed partitioning and the other one is called as dynamic partitioning. In case of fixed partitioning, which is also known as static partitioning, here the main memory is divided into several fixed size partitions. So in case of fixed partitioning, which is also called as static partitioning, the main memory is divided into several fixed size partitions. The partitions can be of same size or it can be of different size. Operating system maintains a table that indicates occupied and unoccupied partitions. So here operating system maintains a table that indicates occupied and unoccupied partitions. Each partitions can hold a single process. So what we can do is we can make a process reside in a partition. The number of partition determines the degree of multiple programming. So since we have said that a partition is capable of hosting a single process, so the number of partition determines the degree of multi-programming. These partitions are made at the time of system generation and remains fixed throughout. So these partitions are made at the time of system generation and remains fixed after that. So let us discuss some of the advantages and disadvantages of fixed partitioning. So it is simple to implement and easy to manage and design. Okay, and disadvantage, it leads to internal fragmentation and the number of partitions. It leads to internal fragmentation, and the other disadvantage is that the number of partitions cannot be changed. Now let us move on to dynamic partitioning. So in case of dynamic partitioning, a process occupies only the required memory. So in case of dynamic partitioning, as stated, a process occupies only the required memory. So here memory is allocated until the physical memory is exhausted or the remaining space is insufficient to hold the requesting process. So a process occupies only the requested memory and the memory is allocated in a manner that the memory allocation takes place unless the physical memory is not exhausted or the remaining free space or remaining space is insufficient to hold the requesting process. Here the partitions used are of variable size and the number of partitions is not defined a priori. So here the partition size is of variable in nature and the number of partitions is not defined a priori. That means we do not have a prior information about the number of partitions. So advantage, it is simple to implement, it is easy to manage and design. Disadvantage, again it leads to internal fragmentation. The number of partitions is specified at the time of, so here the number of partitions specified at the time of system segmentation. So this is one of the major disadvantage of dynamic partition. So this is what dynamic partition is all about. So in today's class, what we have learned about is we have learned about what are the different types of memory management schemes, wherein we have learned about contiguous and non-contiguous memory management scheme, where we have talked about single contiguous memory management scheme and multi-partitioning memory management scheme. We have talked about fixed partitioning and we have talked about dynamic partitioning. Further, we learned about fragmentation. We learned about what is fragmentation. We learned about what are the different types of fragmentation. We have learned about internal fragmentation and external fragmentation. Then we created a distinction between internal and external fragmentation. Then we moved on with the detailed explanation about contiguous memory management scheme and we discussed single contiguous memory management scheme. with its advantages and disadvantages. Then we moved on to multi-partitioning memory management scheme, where we talked about its characteristics and we've talked about its types. And then we moved on to the different types of a multi-partitioning memory management scheme, where we have talked about fixed partitioning and we have talked about dynamic partitioning. So in the next class, we will talk about paging and segmentation. Till then, thank you very much. Have a very good day.